been hanging with everybody.
Let's do it. All right, let's do it. Well, good morning, everyone. I'm just so excited to see such a fantastic turnout this day lunch here. That's really, really good. For those who don't know me, because I see a lot of new faces, my name is Tony Dondola. I'm the outreach coordinator here at the Space Museum. And we're going to be talking today about New Space. And actually an update, because we've covered New Space before in previous lectures. And so this is just going to bring you up to speed as far as what is happening right now. And when I talk about New Space, think about NASA, that's old space. Think about SpaceX, that's New Space. Okay? So basically, government versus private entities and what they're doing in the space business. So right now, you're probably all aware of what's been happened in the past in space tourism. I'm sure a lot of you saw William Shatner go up in the Blue Origin rocket, and also the things that have been happening with Virgin Galactic at Spaceport here in New Mexico. But right now, both of those programs are on hold because both of them have had problems with their last flight attempts that they're going to have to work hard to resolve before they can resume flying again. So there are no tourist flights happening right now. We're going to look at those individually. So you probably all remember the big flight with Mr. Branson. It was July 11th, 2021. It's hard to believe it's been that long, but it was. And they flew right out of here at Spaceport near TRC, New Mexico. And by all appearances, it was a very successful flight. They made their maximum altitude that they needed to get to, be over the Von Karman line, and it looked great. But there was a problem. They violated the airspace. They are given a temporary airspace up to a certain altitude, and that waiver lasts for a couple of hours, and they had a problem with that. But just to review, I'm going to kind of show you a short video about that flight.
Ladies and gentlemen, this here is Mr. Branson, astronaut.
Some people argue with that, but and so there's White Knight, the carrier aircraft, and Unity spacecraft is tucked right in at the bottom there. There's the dropping. And they immediately pitch up and head not straight uphill, but at a very, very high angle. And you can see readouts on the right there of both altitude and speed. They're already at Mach 2.5, and they'll top out at about Mach 3.1, 3.2.
50 seconds approaching Mach 3. There's Mach 3. And 60 seconds, and that is the full duration burn, folks. We are headed to space.
And here's the landing.
Main gear touchdown. And we're going to hold it just like this for a minute before bringing the nose down.
Mr. Branson's
You can see they're already celebrating inside there.
So just imagine a world where people of all ages, all backgrounds, from anywhere, of any gender, of any ethnicity, have equal access to space. And they will in turn, I think, inspire us back here on Earth. If you've ever had a dream, now is the time to make it come true.
I'm kind of looking for my equal access to space too. That's another story and another question. They have given away some spots, so I think there's a good issue. So, as I mentioned, it was grounded after the July 11th flight. And so what happened when that spacecraft reaches its maximum altitude that they planned for, there's what they call a landing cone. And the sharp point of the cone is centered on the runway, and it goes outward like that to altitude. And that cone designates having enough energy to get back to the runway. So you go outside that cone, you're not going to make it back to the runway. So it's really pretty important. They also had an issue with some high winds at altitude. So because they followed the full flight profile and went to the maximum altitude, the winds, they got outside the cone. And they violated their airspace for about 101 seconds. And the FAA does not like you to violate designated airspace. They don't take that very kindly at all. And so they immediately pulled their permission for them to fly. So that was the first problem. Which, really they've been flying a lot, but one of the first real commercial flights, you can expect things like that, little problems. The other problem that they're having is they have redesigned the release mechanism between White Knight and the spacecraft. And they designed it up, they ordered it up from contractors, and because of the supply chain problems post-COVID, they're still waiting for the hardware. And originally they were planning on going back to flight status in the fall of 2023, and they're still kind of looking at that. Realistically, probably early 2024. So they've been shut down from flying for quite a while. So hopefully they can come back and put things together and get their manifest going, because at this point, Virgin at least, Spaceport does other things, but Virgin itself, they don't have any income from this particular project, other than what they're getting. Do they get constant funding from the state of New Mexico?
Yes,
Virgin?
they do.
They do? Yeah. So they've got that, but they've got no revenue from the flights. So anyway, that's what's happening at Spaceport and Virgin. Yes, I already went over all that. So. Having a good time. Looks like a fun thing to do. And what's nice about the way they're doing it is that it's an extended experience, because you have that long flight, dragging you up to altitude, and so there's a long time to really enjoy being in the spacecraft and doing all those kinds of things. Okay, so now let's talk about Blue Origin. They're down at the Corn Ranch down in Texas, which is what, about 4 hours out of El Paso, I think?
I think it's more like 2.
Okay, yeah, really not that far away. And they've been doing real well. They've had a number of paying tourist flights in their spacecraft, and of course, as opposed to something more like the shuttle, this is actually more like a real rocket. I hate to say that, it's probably true. And it's a great way, I think, to have the experience. And that picture on the right, you've got Bezos on the right. That's William Shatner, who's emerging from the capsule after his well-publicized flight. But I want a little aside. The lady in the middle, her name is Sarah Knights. And she is something called the 7th crewman. They have 2 of them. And the duty rotates between the 2 of them. For one flight, you'll be Capcom. For the second flight, you'll actually bring the crew out to the capsule, tuck them in, make sure everything is right, and then you'll meet them after they land and extract them from the capsule. I used to share an office with that lady. We both worked in education at the Museum of Flight up in Seattle. And the reason that I mention this is that New Space is really providing a lot of new opportunities for people to work in the space business. And I think that's really a great example of that and what can actually happen. So I'm real excited for Sarah. I think that's a really great opportunity. But it's also important for young people growing up. Because when I grew up in the 60s, yeah, I wanted to be an astronaut, but there wasn't a chance that was going to happen. Very, very tiny opportunity, but that's not true anymore. So it's definitely exciting times and a good time to be excited about private space industry. So I'm going to show you a video now of exactly what happened. It wasn't a crewed flight where they had the problem. It was just carrying up experimental payloads. They actually have 2 boosters. They have a booster in the capsule that they use for a non-crewed flight, and they have a booster in the capsule that they use for their crewed flights. So this was the booster in capsule that they use for uncrewed.
T-minus 10, 9, 8, 7, 6, 5, 4. Command and start. 2, 1.
Mission
that DE4 engine, it burns very clean. There's usually not much of exhaust on liquid oxygen and hydrogen. It's a very clean burning
The engine
engine.
started at around 3,700 feet MSL. That's how far above mean sea level we are out here at Launch Site 1.
Now I want you to keep your eye on the engine itself because that's where the problem originated.
The E3 engine throttled up as we're going to push up to max Q. Again, that's the point where the aerodynamic stress on the vehicle is at its maximum. Throttle back.
There's a little blip.
Continue on up to space.
Another little blip, and then, yep, the engine goes away. So what you're seeing now is the launch escape system detected the error. It kicked in, fired that rocket underneath the capsule, separated from the booster, and it's heading upstairs really, really quick. Now, if this had been a crewed flight, it would have been pretty tough on the passengers. You pull pretty heavy G's when you do this escape maneuver, and there's a lot of motion. I'm just very glad there was no one aboard. So it's going to continue on up. It's already started to fall. Altitude is decreasing, speed is increasing. It's basically in free fall right now. And they're just hoping against hope that everything else will work as it's supposed to. So you gotta wait for the drogue chutes to come out. 3 small white parachutes, and the function of the drogues is to slow you down to about 300 miles an hour, stabilize your descent speed, and also stabilize the capsule. So,
This wasn't planned, and we don't have any details yet.
right.
But our crew capsule was able to escape successfully. We'll follow its progress through landing.
And did
As
you
can
notice
see, the drones
that
have deployed,
there
and
was
the mains
absolutely no commentary from the time the incident
Yeah.
happened? They obviously did not have a canned script for that. So, you know, she was waiting for someone else to tell her what to say, I'm sure.
An anomaly.
Yeah, exactly.
What happened to the rocket?
It crashed. Because that booster comes back and uses its engine to land, just like SpaceX does with Falcon 9. Well, with no engine, you weren't going to make a landing.
How far from?
A couple miles from the launch. It was on the Corn Ranch, but yeah, it was within their property, so you know, it wasn't in San Antonio or anything like that.
Is that Corn Ranch, is that near Marfa, Texas, or where is it?
Van Horn. It's Van Horn, yeah, it'd be the closest. Yeah, Marfa's kind of the other way. But it's definitely, you know, accessible. I'm not sure how they're handling anybody who wants to go and see a launch, or whether they're even accommodating that yet. But from outside the property, you can certainly see it. As a matter of fact, when Virgin Galactic starts flying again, we'll actually be able to see that, we're told, from here, looking back over in that direction. So at least the upper part of the asset, the powered part of the asset, should be visible.
All right, the mains are out. You see that they're reefed. They're going to be expanding. As the mains inflate, the capsule will stabilize. That's looking like a successful execution for the crew capsule and escape system.
What's the elevation that those main parachutes came up?
I would say typically 10,000 feet ASL, or AGL, I'm sorry, above ground level. So what the actual altitude is, that plus whatever the altitude is at ground level. But usually about 10,000 feet.
Why do they need shroud lines that are so long between the capsule and the parachutes?
You know, I'm not really sure what the answer to that question is. It might actually just enhance the stability of the whole system as it comes down, so you don't get a lot of rocking back and forth. That's the only thing that I can think of that would account for that. So the last thing it's got to do is land softly. So, you know, in a way, it's a really good test of the system because it would have been survivable.
Soyuz lands the same way.
Soyuz lands the same way. When you see this capsule land, which should be happening fairly shortly, you'll notice that it disappears in a big cloud of dirt. And what there is, when they get down to about a meter above the ground,
Under its 3 main chutes. You can see this
they
West
fire
Texas
this little kick
mountains
engine,
the background.
and it
As we
softens.
come down
It acts
towards
like an
the desert
airbag
floor,
almost,
We're going to expect
and
that retro
really
thrust
softens the
system to
impact.
fire. Again, that will take out most of the energy on the landing in addition to the parachutes. You'll see a
Yeah, and
big
Soyuz
cloud of dust
does
out
the
there in the
same
desert.
thing. So it's a good, it's a good way to do it, and you should see that happening very shortly.
That is the Boeing one, I saw a picture of that, it looked like it had a big balloon underneath it.
There you go. So it looks rough.
You can see how our backup
But
safety
it's-
systems kicked in today
it's not.
to keep our payload safe during an off-nominal situation. Safety is our highest value at Blue Origin. It's why we built so much redundancy into the system. We're going to close out the webcast for today. We'll share more information about the flight on Blue Origin's Twitter feed as we can. Thank you for joining us for today's webcast.
Well, and the problem was there wasn't more information. And this is one problem with private space flight, because it's not like NASA. It pretty much has to be pretty transparent and get the information out there right away. Private companies don't need to do that, really don't want to do that, because they're still very conscious about other entities copying what they do or stealing their technology. But I will follow Blue about this, and that they have yet to really present any specific information on what exactly went wrong with the engine. We know that we lost the engine, but other than that, they really haven't said much. You can go to their website, there's nothing. So, and I don't have any information. I don't know when they are going to start flying again. They may not even know when they're going to start flying again. Yes?
Did they say what the original purpose of the test flight was?
There were experiments on board, because during these flights there is a...
Do you know what experiment?
I don't know what experiments, no. But I'm sure they were short duration microgravity experiments. It would make the most sense. So that's what's happening with both Virgin Galactic and with Blue Origin, and I hope that they both make a swift recovery and continue flying people. I think it's a great thing. I'm going to diverge a little bit, because there's a lot more going on in private space rather than just those two things. And one company that I've really been impressed with lately is a company called Rocket Lab. They're out of New Zealand, and they have their Electron rocket, which is a small rocket dedicated to access for small payloads, which is really a growing part of the satellite market right now. Payloads are getting smaller, satellites are getting smaller, so there's a greater demand now. You're not going to hire out a Falcon 9 to put a 200-pound satellite in orbit. You'd be piggybacking with other people. So anyway, 33 launches to date, 155 satellites deployed, and it has 3 dedicated launch pads. New Zealand was originally their primary one. I think they also began in New Guinea, and they just recently had a flight from Wallops Island in Virginia. So now they have a U.S. flight capability, which is really great for people in the U.S. that want to fly payloads. And it's a very interesting, it's a very, very interesting rocket. It's very, very different. It's very innovative. And it's called Electron because it's you could almost consider it to be an electric rocket. So rocket engines have these very powerful turbines that force the fuel, right, from the tanks into the combustion chamber. And usually they have a small rocket or burner that will actually use the fuel that's being used for the rocket to power the turbines, okay? Very complex, a lot of plumbing, a lot of things that can kind of go wrong with that kind of an engine. Their engines are very, very simple. As a matter of fact, it weighs about 26 kilos. You almost just cradle it in your arm. But they still have turbo pumps, but they're electric powered. They're powered by electric motors. And so it carries a big pack of lithium-ion batteries, just like you would have in an electric car, to power the turbines. So it's a very neat system. And if you look at the turbines themselves are only about the size of a Coke can. But they spin at, I think it's around 48,000 RPM, really, really fast. But it's a system that's worked really well for them. And they also have an upgrade to this rocket called Neutron that's still on the drawing boards right now. But it's a very short, squat, fat-looking rocket with fins, very sci-fi looking. It's all carbon fiber, just as this rocket is, so it's extremely light. And it's going to be able to take much larger payloads, and it's going to be 100% reusable. And one real cool thing about it, because it does have a second stage to kick the payload into orbit. And you know how SpaceX has struggled with the fairings that cover the payloads? At a certain altitude, the fairings will drop off. Well, on this new rocket, the fairings don't drop off. They just open. And the kicker stage flies out, and then they close again, and the whole thing comes down as a streamlined package, which is pretty interesting. So that'll definitely be one to watch. So here's an actual recovery. Yeah. This is a recovery of the
Oh,
booster.
here we go. We've got our first glimpse of it.
So what they're going to do, they're using a helicopter to snag it right out of the air. Because they're using carbon fiber and the rocket's not that big anyway, they can do that successfully. So no one's real sure what's happened yet, but now they know. So that's great because you don't have to carry the extra fuel, right? In order to do a landing, right? It doesn't have to go into the water and be affected by all that corrosion that will happen. So it's really a great way to do it. So I wish them much success with that. It's a very innovative thing that they're doing. Okay, so now the 10,000-pound gorilla in the room in terms of private space, and that is SpaceX. And they always provide us with a lot of excitement, a lot of thrills and spills and massive explosions, because that's how their development process works, And the vehicle that we're looking at is basically Starship. It consists of two parts. That black section at the top, that is the Starship spacecraft itself. And below that, in gleaming stainless steel, is the Star Booster. And this is, I've got it next to, I'll show you the next slide here. I've got it next to SLS to give you a sense of scale, because there's no way to get a sense of scale from that photograph. This is the largest, most powerful rocket ever designed, and when it flies, it'll be the largest, most powerful rocket that's been flown to date. And to give you an idea of that, you can get an idea of the size. It's taller than a Saturn V, and it has about 2.5 times the thrust of a Saturn V. It has 33 Raptor 2 main engines in that booster. So the amount of power that this thing has is just unbelievable. And nobody's ever really seen anything like it. So they've been able to test the Starship section with drop tests, not drop tests, but they flew it up to about 10,000 feet, and then they let it come back down, because it comes back down in a very unique way. And I'll show you an animation in a little bit, I'll explain that a little bit more. And then it finally flips and lands on its engine. So it's quite an interesting way of getting a payload back to the ground. I'm going to show you a video. What they're doing right now is they're getting to the point where they're doing engine testing, so what they call static fires. So we'll have the spacecraft on the pad, they'll fire up some or all of the engines for 10, 15 seconds, just like that. And that tests a lot of things. It tests the engines, it tests everything that's associated with that and their procedures, and it also tests the structure, because there's going to be a lot of vibration and acoustic effects and things like that. So these are really important tests for them to carry out. And this is a test. I love this just because of the angle. This is taken by a drone, and this is just Starship firing all of its engines. So if you're an unlucky seagull, this is what you're going to see. So it's really beautiful. And one side of that spacecraft is covered with thermal tiles, just like the space shuttle. They're a little bit different in that they're all pretty much the same, except for some areas. They're about the size of a dinner plate, and so it's in a honeycomb pattern. So shuttle-like tiles, but a much more cost-effective way of applying that kind of technology for thermal protection. Now, along with testing Starship, we've got one more to go. And they've done a number of these tests. So they're pretty confident with Starship, at least that part of the rocket. Space.com. Now they're also starting to do the same thing with the big booster. The first test, and I believe that's what this is, was a 7-engine test. So we just fired 7 out of 33 of the engines. And so they're starting that very, very important test campaign. They've also done tests firing up to 14 of the main engines in the booster. And they've discovered some interesting things. You might get a sense of it right there. Because this is a very powerful rocket, especially when they fire all 33 engines. And what's unique about this, they don't have a flame trench. They don't have a flame diverter. It's just flat concrete underneath that launch mount. And as we'll see in a little bit, this is definitely a 14-engine test. But that is slightly problematic. And it's interesting to me because I'm sure the engineers looked at it very thoroughly and they have their expectations. But they didn't necessarily pan out the way they thought they would pan out. All right, I'm going to stop this now because we've seen much of this test. When I did this at home, PowerPoint went haywire, so hopefully it won't. There we go. Okay. So now this particular clip is going to show you really what the problem is. So watch for flying debris. That's concrete. Okay? Those are chunks of concrete. Look at the puddle. Watch the puddle.
Ooh. Oh my gosh.
So obviously that's a problem. And they've had to dig out and refurbish the concrete underneath the launch mount after every one of these tests because it's just tearing it up. I think their solution right now is they've added to their water deluge system. So they're going to be shooting a lot of water, and I think there's also nitrogen gas that's mixed in with the water to make it a little bit more effective, and to try to mitigate the force of those engines hitting the concrete and also hitting the launch mount and all that delicate equipment in there. And also to diminish, to help bring down the acoustic and shockwave effects. If you remember the first flight of the shuttle, STS-1, as soon as those boosters ignited and the main engines ignited, there was a shockwave that went down and hit the ground, came right back up at the vehicle, and actually did some damage. So the engineers hadn't quite expected to get that much of an effect. And so they made some changes so that that wouldn't happen again. Probably the loudest shuttle launch because of that. So SpaceX has the same problem. So basically, they've done all the tests that you've seen. They have subsequently destacked. Oh no, one more thing that they did. Get to that in a second. They did a full wet dress rehearsal of the full stack. Meaning you're on the pad, you fully fuel the vehicle, both Starship and the booster, which is a great test of the launch mount and all the associated stuff. You know, it's not going to crumble or do anything weird with that tremendous load on board. And they went through a complete simulated countdown, all the way to engine ignition, called a wet dress rehearsal. And by all accounts, there were no major anomalies or problems with that, which is great, because it is a major test that you have to get through before you can think about flying. And they have subsequently destacked the rocket. Both Starship and the booster have gone back to Star Factory for full inspection and maybe a little bit of refurbishment. And the next time it comes out to the pad, they'll bring the booster out, they'll do the 33 engine test, they'll stack Starship on, and then at that point they will be ready for the big show. So they were supposed to do the 33 engine test sometime this week. The road closures were revoked, so now they're looking possibly at doing it next week. So keep your eye on YouTube. I don't know that any networks will cover this, but there'll definitely be coverage on YouTube. So keep an eye on that, because the first time all 33 engine goes, that's going to be a moment. That is really going to be something. If the 33 engine test succeeds, this is what will happen with the first test flight. And keep in mind, this first test flight is probably only a couple of months away if the engine test is good.
There won't be people in it though.
There won't be people in it. This is just to get the thing, Starship into orbit, test the booster, and all of that. Now there are some details that are a little different. This program moves so quickly from the time this animation was done to now. You can actually see differences in the rocket, differences in the launch tower and the facility and everything. But basically it gives you an idea of what's going to happen.
What are these launches rate on the earthquake scale?
A lot. Nobody knows. It's not launched yet. It's not full. It's not flown. So
Well, Saturn V, they could pick it up on seismographs in New England.
yeah. Oh yeah. Saturn V. So think about 2.5 Saturn V's taking off. And there's still going to be concrete flying everywhere. And for those who don't know, this will be happening down in Boca Chica, Texas. And it's right down at the very lower tip. Yeah, Brownsville. Right on the water there.
Is it on South Conroe?
It's very close. Very close. That's why they had to go through, they were delayed quite a while with environmental review, because it's a wetlands area, it's a protected area adjacent to the launch facilities. So they had to jump through a lot of hoops to get permission to actually fly. That's weird. It looks like a cow, I know, and it's just the ice. A lot of ice forms on the booster. That would probably all fall off in the first couple of seconds, just like it did with the Saturn V.
Since we live in an era of CG, you can't tell what's real anymore.
It's getting close, isn't it? It's getting close. Okay, so there's the booster dropping away. Starship will continue on into orbit. And the booster is going to do its flip, if you're familiar with the flights of the Falcon 9. Kind of the same thing. Except I don't think there's going to be a boost back burn. I think it's just going to follow its natural trajectory. So there's going to be some heating during the entry. And it's going to fall like a stone. Now, it's not going to attempt to land on land. It's going to land on the ocean. So it's going to use its engine. You'll see that firing up in just a minute here, and it will hopefully come to zero velocity once it reaches zero altitude. And they did the same thing with the Falcon 9. They did in their early testing, was to just land on the water and to verify that everything was going to work correctly. And those fins up top that you see sticking out, that's just for terminal guidance. That's to help aerodynamically guide the rocket, put it on the correct path. And there it goes in the water. That one they won't be using again. Stainless steel and seawater didn't like each other. Meanwhile, aboard Starship, it's going to prepare to do pretty much the same thing. So it's gone almost all the way around the Earth. And it's actually not quite at orbit. It's a little bit under velocity for orbit. It's more like on a ballistic missile trajectory, but it's good enough for them to test and get the data that they need. So what it will do, as all spacecraft in Earth orbit do, is it'll do a flip maneuver so that the engines are pointed in the direction of travel, and it'll do a very, very short burn to just reduce their velocity just enough so that it starts to re-enter the atmosphere. And that's going to happen, I think, in the vicinity of Hawaii. I'm not sure where east or west, but in that part of the ocean. It's got 3 sea level engines and 3 vacuum engines. The vacuum engines are the ones with the big engine mouths. Yes?
Silly question, but you said it follows a ballistic missile pattern.
Yes.
How is it going to be determined that it's in fact a flight, not a missile, by some foreign government?
Well, all foreign governments are going to be well aware of what we're doing and will all have been apprised of it. It's not going to be a secret or a surprise to anybody. And other than that, I'm not really sure. It's not been a problem with tests in the past of other systems, so it should be fine. So here it is doing its flip. very short end. There it comes, there it goes. So now it will have to flip back over to present its thermal tiles and its belly in its direction of travel. Very much like the Space Shuttle did, but the angles are much higher. The Space Shuttle was angled up about 45 degrees. This is almost vertical. And this is where those tiles have to work. And I'm not sure that Elon has a ton of confidence. If SpaceX gets to this point, that they will consider the flight to be a success. They know it's a test flight. The way they test is through failure, actually. So they'll be thrilled to get to this point. If the booster doesn't blow up on the pad or 100 feet up, they'll be thrilled as well. And all of South Texas will be thrilled if that doesn't happen. So this is the iffiest part of the flight.
Like there's a benefit to testing two failures, so you know where your failure point is.
Sure, oh yeah, exactly, exactly. I mean, their first version of Starship kind of looked like a flying grain silo. It's just, you know, just an engine in a can, and, but they got the data that they needed to move forward. Now you see these fins on the side. I'm not quite sure, they're not really ailerons, they're aero surfaces. And what they're going to do now is they're going to maintain the spacecraft in a belly flop position, right? So think of it as a skydiver, right? When a skydiver is flat, he's got his arms and legs out, you're maximizing the amount of drag that you're generating, okay? So they want to get rid of all of that energy just by using the atmosphere. And it's a very effective way to do it. So it's really kind of genius the way they set this up. But as you'll see, it also sets up for a very terrifying maneuver at the very end. And it's going to land on the ocean just like the booster did. And what it's going to do is it's going to fire up some of its engines. And it's going to do what's called a flip maneuver. And they've actually tested this part of the flight. And there it goes. So if we're lucky, if everything goes well, we will get to see this actually happen, probably in the first quarter of this year, hopefully. If there's a major mishap, the booster explodes, then it's going to be a long time before they fly.
There'll be a YouTube on it.
Yes. Oh, yes. There'll be lots of YouTubes on it. So, other thing about SpaceX, even though they're a private company, they are working with NASA. And there is a lunar landing variant of Starship. That's what you're looking at right here, which is just specifically designed to land on the moon. And NASA has contracted them to do that because they're going to be working with NASA on the SLS. And this is going to be part, when the SLS actually gets to the point of they're wanting to land people on the moon, this is the lander that's going to do it. Which, it's really interesting because the crew is way, way, way up at the top, right? They're going to have to climb a really long ladder or take an elevator to get down to the surface. So this is not a lunar module, okay? This is a whole different animal. And they're working on that development right now. And the thing about Starship, when we get into regular missions, once Starship reaches orbit, it's empty. It needs all the fuel that it can carry just to get that large spacecraft into orbit. So the plan is that they're going to launch another one full of fuel, rendezvous, link up, refuel the original Starship. Now you have Starship sitting in low Earth orbit, right? Fully fueled. It can take 100 tons anywhere in the solar system. So this is really the key to really getting out there and utilizing the resources, getting people out there, getting researchers out there. So if this all works, which is kind of an if at this point, but if it all works, it is really going to open up the solar system for all mankind. It's going to be a really great thing. And of course, one of Elon's major impetuses for doing this is he wants to colonize Mars. And you need a spacecraft like this to do that. And he's producing these at an incredible rate. There are 3 or 4 of these starships, if you go down to Boca Chica, that are just sitting, waiting. And they're making more, and they're making more, and they're making more. They've also started a facility at Kennedy Space Center, where they're also have a star factory down there, and once it's ready, it's going to start producing. Because I think for seriously doing something like colonizing Mars, you need to get like 1 billion people on the surface. And you're not going to do that with a flight every 2.5 years, such as NASA does. You're going to have to fly a couple of times a week. So it's going to be very, very interesting. I think the future is looking very bright for new space, private space. Any questions? Yes?
I watched a very interesting YouTube video the other day on the centrifugal launcher over at
Oh, spin launch.
Spin Launch.
Yeah.
And I mean, that's in our backyard, so.
Yes, it is. The company's out in California. The test facility is out very close to Spaceport. And it makes quite a racket when they spin that thing up too. But yeah, and I think that, yeah, you can use it for very specific payloads from Earth's surface, but there's a lot of G-forces and a lot of heating, you know. It actually spins, that whole chamber is in a vacuum. They have to do that. And then it goes through a membrane when they're released, and then it hits the atmosphere like a brick wall. I think the major utility for that won't be here, but it'll be places that don't have atmospheres, like the moon. If you want to mine the moon, right, and you want to get that raw material into Earth orbit, it's a fantastic way to do it. You just spin it, launch it out, and you've got it, you know. Same thing for mining asteroids. I know that the linear mass drivers have been an idea for a long time on doing that, but that's spin launch mechanism. And on the moon, you don't even have to have it enclosed, right? Because it's all vacuum, so it's the perfect technology for that kind of thing. So it'll be fun to watch. Yes.
You said that, quote, when Virgin Galactic starts flying again, close quote.
Yes.
As someone who studied that company for 15 years, you're far more optimistic than I am. Stocks in the toilet, they're burning through $40 to $100 million a quarter with no revenue coming in.
Right.
You've got 2 shareholder lawsuits. I've read them both. They're very strong about Branson defrauding shareholders, Chamath Palihapitiya defrauding shareholders. What makes you think they're going to start flying again in the next?
Because I'm ever hopeful. And the people that I've talked to from Virgin, they're ever hopeful, and they haven't given up. Now, you know, money is what drives everything, and I'm sure just like any other private company, if they get to the point where it just isn't viable, then it'll be a different story. But right now, as of today, they are planning on resuming flights. I mean, they do have a big investment in the technology, so that's, you know, you have to realize that. So, good question. Yes?
Where are they getting the scientists? Did they poach a lot from the old NASA?
Oh, you mean the engineers?
The engineers, yeah, the folks who put all this.
I don't think they needed to poach. I think there's a lot of engineers who would be very excited to work within the space industry on that kind of a project. And so, you know, there's no shortage of engineers to come and work on projects like this. Same thing for SpaceX and all the other companies. Yes, in the back.
Corn Ranch, how? What is their area of that they can launch? Unlike Virgin, you know, Galactic, they're up against military areas.
Right.
Where is Corn Ranch allowed their spectrum of like launch?
Pretty much, I mean, Kathy, correct me if I'm wrong, but I think the Corn Ranch facility is large enough. I mean, basically they're going straight up.
Okay.
And they're coming more or less straight down. So all of the operations happen, if you take the borders and just go straight up with them, all happens within that.
So they don't have really military restrictions then around them, like
I
Virgin
I
Galactic.
don't believe so. And usually the boosters only when they land, the booster landing site is only a mile or two away from the launch pad. So they're fairly close to each other. So they're not going sideways, just going straight up. Yes.
What would you, if I wanted to encourage one of my nephews that just graduated high school, a field to, if we want to get into space work, what kind of degrees would you be looking for?
It's pretty diverse. I mean, I think a sure thing would be an engineering degree. That would be probably one of the main paths.
Thermodynamics, optics, just general science. I mean, it's
yeah, all of the above. Structural, electrical, you know, all of that stuff is a part of it. And I know that SpaceX advertises extensively for new people. The last ad I saw from them, they were looking for someone to manage the launch tower at Kennedy Space Center that they're building. So, they're always looking for new people. And as I mentioned before, no matter how you want to get into it, as an engineer, as an astronaut, as a scientist, as a publicist, the opportunities are immense right now. And if new space continues to grow, which I think it will, because once these companies really start making money, particularly you're going to start looking at things like using resources in space, like asteroid mining and things like that. If there's a buck to be made, there are going to be people who are going to be making. No question about it. Yes?
The pre-made waiting to go to Mars, you said there's a whole bunch on the
Right.
launch. Is that allowed for redesign, or is there?
Absolutely, and they're still in that phase. And after this first test flight, they will look at things that didn't work quite the way they had planned, and they'll go back and they'll do redesign and they'll do modifications. So everything that comes out of the factory right now is a little bit different from the last one that came out of the factory. Because SpaceX learns by doing, whereas opposed to, let's say, NASA, right? They design the thing to the last rivet and bolt. They contract it out, put it on the pad, fly it, right? They don't have the SpaceX test routine is very, very different. The first Starships that flew were very rudimentary. They looked, they were sort of, the skin had dents in it. It was very, very rough looking. It was basically just fuel tanks and engines. But that's all they needed. And as they did more tests, Starship got sleeker and sleeker and sleeker until the last test that they did, it looked really beautiful. Very smooth, gleaming stainless steel. So that's just the way SpaceX does it. That's how they operate.
So I'd rather be in the last one, Bill.
Yes. Yeah, good point.
The lowest bidder.
Yeah, good point, good point. I think I would too, yeah. Yes.
You've mentioned that Virgin violated a cone, your very first slide there, violated this cone of airspace?
They didn't violate the cone. The cone is within the designated airspace, and they violated the designated airspace.
Okay. At what altitude were they when they did that? You have any idea?
I would imagine that it would be very near the top of their trajectory, but I don't know for sure, which would be about 55 miles. But I don't know exactly. I don't have the details on
55?
Altitude, yeah.
55.
Yeah. So, yeah, but I don't have the details on exactly where the incursion was. I think it was to the west, but don't quote me on that because I'm not really sure.
That was accidental because of the winds, right?
Yeah, they didn't, no one ever plans to violate their designated airspace, so that would be a very bad idea. FAA doesn't have a sense of humor about those kinds of things. Yes?
One more.
Yeah.
You had mentioned New Zealand as
Rocket
another
Lab.
country
Yeah.
active. Isn't Japan mounting a lunar exploration or landing?
I've heard, yeah, what's that project called?
I've heard about it, and I can't talk to it, but I did glance and see something about that about a week ago, so it's certainly worth looking at.
And then you have the European Space Agency, you have China is very active in a manned program. They have a space station. They've landed a rover on Mars. They've been doing things, pretty incredible things, which we know very little about because they're not very open with their program. But they're really, as far as competition in space, really the main competitor to the United States. And there's no question about it. So they're the people to watch.
Strange how they look a lot like SpaceX equipment.
Yeah, well, once you know something works, and physics tends to drive us while our cars look so much the same. It's physics that's dictating that, the aerodynamics and what have you. So you do tend to converge on the same solutions if it's the best solution.
That works.
Yeah. Okay, well, thank you all for coming today. We really appreciate it. I'm going to bring up Kathy Harper she's going to let you know about what's happening at the museum over the next couple of weeks.